Lesson 3 is rates of change in other applications. In this lesson, we shift our focus from physics and vertical motion problems into the world of economics, business, calculus, and other rates of change. Okay, so we're still going to be talking about the same type of stuff, but different scenarios. So instead of physics, we're going to go business. So, when business owners calculate profits for their company, many different factors must be considered. For this course, we're going to explore marginal analysis as it relates to quantities such as fixed costs, revenues, and profits. We've seen similar exercises with a linear cost function, but we're going to explore scenarios of a nonlinear nature. So, vocabulary. Cost function. Okay, your cost function is typically defined as C of X, and it finds the total cost of producing X units. So your input being the X is the number of units, the output being the total cost. Average cost function is a typical one. And you'll notice right there, C bar, we used X bar somewhere along the line for mean. And if we didn't, then maybe we do that this year in calculus. But at some point I felt like, no, X bar hasn't popped up. Maybe that's a calc thing then. But when you see the bar here, that's another way to talk about average. So your average cost function, in order to find the average cost function, you're doing C of X divided by X. And so that's your total cost divided by the number of units, and it includes the fixed operating cost. The revenue function, what's revenue? That's it's not exactly the profit, but it's the money you are bringing in, yes?
Yeah.
Okay. Maybe.
Net income.
Something along those lines. Only because I'm not 100% confident with my vocabulary is why I'm not gonna, But there is a slight difference between revenue and profit, okay? So revenue, it's the total revenue received for the sale of X units, okay? Now profit, notice what it says about profit here. Profit is equal to revenue minus the cost. So your profit is that amount that you earn after you pay off your cost. Okay, revenue is everything that's coming in. So that's all the money coming in. But only piece considered profit is the extra you have after you pay off, pay all the vendors and whatever you need to cover your cost. Notice, this is profit. Notice they don't use P of X. I'm not 100% sure why. Well, I guess it talks about down here. But pi of X. Okay? So when you see pi of X, that is the profit function in the business world. It says, note, in the business world, the Greek letter for P, that is pi, is commonly used to name profit. This helps have different variables for price and profit. So when you see P, it's going to be price. When you see pi, it's going to be profit. Okay? So, a little bit of vocabulary there. Let's go down. What did I just hit? Not what I wanted to hit. There we go. Marginal analysis. In marginal analysis, we have a method of estimating how revenue, costs, and profits change when the input increases by one additional item. Okay? If the graph of a nonlinear function is not curving too rapidly near the point of tangency, then the slope of the tangent line can be used to give us a close approximation for how the quantities change in a relatively small neighborhood. Okay, so the idea of when you get one more item, what's going on? So marginal cost, abbreviated as MC, is equal to C prime. So the derivative of cost, and marginal cost, it's the rate of change of the cost function, thus the derivative. It approximates the cost to produce one more item. That is the additional cost at the margin. To find an exact amount to produce one more item, you use the original cost function. Okay, so some vocabulary there to be able to come back to. Definitely marginal cost, and it's the derivative of cost. It's the rate of change of cost. And Key is cost to produce one more item, the additional cost at the margin. And then the other key piece, the exact amount to produce one more item, use the original cost function. Keep in mind, if C of X is the cost of X items, C of X plus 1 is the cost of X items plus 1. So that C of X plus 1 is the cost of one more item. Okay, let's look at example 1. The cost to translate documents into another language is a function of the number of pages. The cost is given by C of P. They give us an equation there. So that's the cost to produce P number of pages. Calculate the marginal cost at the production level of 10 pages. Explain what this means in context to the scenario and how does this compare to the exact cost to translate 10 pages. What? Where do I have that written in there? Okay. Okay, so marginal cost for it said production, which threw me off for a moment, but the translation of 10 pages. Okay? So, marginal cost. What did it talk about with marginal cost? If we're going back up and looking at marginal cost, it's equivalent to, notice right here, it talks about it's equivalent to C prime of X, right? Although, what are we looking for? Not of X, we're looking for what?
P.
Not P even, specifically. Marginal cost at 10 pages, right? Okay. Oh, that's why I've written calculator. That's why I don't have much of the work shown because it was all done on the calculator, I think.
But where's the root? Can we just plug in 10 to the equation? The derivative first. Take the derivative. Then you plug in.
Yeah. And this is where I guess I have written in right here that calculator, so I must have done this one on the calculator. I'm not sure why, other than,
It's so easy.
I mean, it's not a difficult thing either way, but I did do this on the calculator, so can't complain. It's good practice on the calculator, and you guys have complained so long.
Is this going to be a calculator?
So officially,
Oh, here we go.
no, officially, there's two, the way the test is, there's two parts. There's a non-calculator part and a calculator part. Now, I need to double check, but I feel like in the past, when it comes down to the test for this unit, I usually end up just doing it all calculator aloud. Okay? I need to go back and look at my past tests and see what I did and that, but, which I need to check for the quiz too. But I think it will all be calculator. So, okay. So, C prime of 10. Could you just put it in on the calculator?
Yeah, how did you do that? Yeah.
Could you just do, if we don't have to keep using this equation, which you might have to keep using this equation, might you want to type it in on y equals?
Sure.
You could, because we do have another piece of this that we're going to talk about. 002 x to the third minus 0.1 x squared plus 8.75x. So now, if I just want to do C prime of 10, that's going to be what? The derivative evaluated at 10? Could you you do an inderiv on that? I had mine plugged into Y2. There's a glare there, so you can't see what my calculator says. Because your guys giving the same thing, 7.35, a bunch of zeros, and then 2. Okay. Which is essentially what? 7.35, right? Now, that they asked us to produce the marginal cost. Now, what was marginal cost? It's the rate of change of the cost function. It's also what? It approximates the cost to produce one more item. Now, they did ask us to compare. What did they ask us to compare it to? How's this compared to the exact cost to translate 10 pages? In other words, if we are finding the exact cost of the 11th item. How can we find the exact cost to produce one more item? Well, so to find the exact cost to produce one more item, do right here, C of x plus 1 minus C of x, which is doing C of 11 minus C of 10. So it's C of 11 minus C of 10. And this is why I said, might you I don't know what I just did there. I hopped into the graph. I'm struggling with my buttons today. They're not exactly the same though, right? Similar but not the same. Okay, C of 11, it's what? 86.81 minus C of 10, 79.5, and so you are at 731. Okay, so very much similar, just not quite the same. Okay, so the marginal cost was 735. The exact cost was 731. And they asked us to explain the, sorry, my brain is struggling with this problem right now. Explain what this means in context to the scenario. This 735, it was the cost to produce what? The one extra item, which is the what number item? The 11th item, right? Okay, and then this was just the exact cost. Okay, noticing you get very much the same. So C prime of 10 represents the cost to produce one more item. In this case, it's the 11th page. Or translate the 11th page, whatever. I'm going to say it represents the cost to produce one more item, which in this case is the 11th page. Okay. I'm debating. Where am I at on time?
About like 20 minutes. 50. Wait.
I think I'm going to. No. No.
I agree.
I'm gonna skip 2 and come back to 2 tomorrow because my brain needs to wrap itself around 2 a little bit better before I try and explain it. Like, I didn't think to double check this and prep this piece because I thought, oh yeah, I'm good with this. I always struggle with this graph a little bit. So I will be better off if I'm going to save 2 for tomorrow. We'll go to 3 and we'll come back. We'll go as far as we can, but we'll come back to 2 tomorrow. Fair enough? Is that?
Yeah.
Okay. Okay, let's look at 3. I think 3 will be a more straightforward problem that I can handle. The cost of producing a set of Bluetooth headphones is given by the production manager as C of X. Okay, some basic questions here. First of all, they ask us to find the marginal cost. Then use this function to estimate how fast the cost is going if the company produces 100 sets of headphones. So first of all, how do we find marginal cost? Derivative, yes? Okay. So in order to find marginal cost, we're going to find the derivative. Easy enough derivative. Let's do it by hand. What do you get? $50 plus 200x. Okay. There is your marginal cost function. Then use this function to estimate how fast the cost is going up if the company produces 100 sets of headphones. So now what? Plug in 100. So 50 plus 200 times 100. What is 200 times 100? 2 plus 50?
52.
52. 52 what? $52. And officially it's how fast the cost is going up. So this is $52 per headphone.
It's not per headphones, right?
No. No. It is just a single derivative. So it's just a rate. It's just like equivalent to velocity, essentially. So, just something per something. No squareds here. Save that for second derivatives. Okay. B. Compare your result from part A to the exact cost of producing the 101st set of Bluetooth headphones.
So you have to plug this into the first one. Yeah. First equation. C.
So what are we doing here to find the 101st set?
Plug in 101. Oh wait, no. Wait, do 101 minus 100. Yeah.
Okay. The cost of 101 minus the cost of 100. And this is going to provide us the cost of the 101st set. Is this a calculator problem at this point?
Can't be.
I don't have any work written down for it in my notes, so I'm going with it was probably a calculator problem. I just have something minus something here for my answer. That's not right. Is it? Nope. What did I type in wrong?
See what you get. I got 52.0. That's what I got.
What'd you get?
52.01.
As you should.
Nice.
Why am I not? How am I getting 64?
You did.
Oh, there's a minus. It's supposed to be a plus.
You did times 100.
There we go. That's what my first one should have been. I had a minus. It should have been plus. Then what I was going to do is just change all my 101s to 100. Because in that scenario, if I don't have to keep using this equation, that's just as quick, isn't it? Now, if I'm going to use this equation more, is it smart to also plug it into your y equals? It is. There's, So you end up with 6652.01 minus 6600, which is 5201. Okay. Let's see. It just said compare your results. I mean, we've talked about it, right? Are they very much similar? Very much similar? Very much the same? Yeah, 1 penny different.
Marginal cost, like average, basically. Average cost. Like average rate.
It's the official rate because it's a derivative. So it's the rate of change, whereas this is the, I hesitate to use the word average, but I see what you're saying. Does that, it's the rate of change here versus the exact cost. So, yeah, kind of average. I just hesitate to put that official word with it. I'm trying to come up with a better word. I just don't have it right now. So, okay. And this is why I hesitate to throw the word average, because C is find the average cost function. Notice it says C bar, and evaluate C bar at 100. Explain the meaning and context of the scenario. So, how do we find the average cost function, or C bar? You know what? I know. X bar comes up in Algebra 2 now.
Really?
Did it not come up in Algebra 2 when you guys were
That
there?
sounds vaguely familiar.
Did we used a little bit of Excel on the iPads to do some stuff, didn't we?
Like, we took algebra 2?
Yes, you had me for Algebra 2.
Oh, yeah.
You might have slept through Algebra 2. I don't know.
No, that was more pre-code. Wait. That was algebra.
There we go.
I don't
He's
think
grown
I
up a
remember
little
doing Excel.
Yeah, I don't remember.
Were you guys in my new curriculum? You were, weren't you?
Yeah, we were the first.
You were the first group, so we did some Excel. X bar was, you guys had X bar then, but it was, yeah. Okay, anyways, okay.
T-bar.
C bar. How do we find C bar? If you flip back to the previous page, how does it ask us to find the
C of the X over X.
average cost function is C of X divided by X. Okay? What is C of X?
52.
Oh.
No. C of X. I'm not putting in a number yet.
Oh, the equation.
C of X is that equation, yes?
Yeah.
1500 plus 50x plus 0.101x squared, all divided by x. Now, could that be cleaned up a little bit? It can. And in terms of cleaning this up, basically what I would do is take each term on top divides by x. Now, they all clean up nicely with the exception of the first one. 1500 divided by x is just going to be, I'm going to write it as 1500 divided by x. If you wanted to, you could say 1500 x to the negative first. But the others clean up. 50x divided by x is 50. 0.01x squared divided by x is 0.01x. Okay, so officially that is your C-bar function, or your average cost. And then what were we asked to do?
Find C bar of 100.
So now I'm going to plug in 100. 1,500 divided by 100 plus 50 plus 0.01 times 100. Let's see, 1,500 divided by 100, 15 plus 50. What's 1/100th times 100? 1.
That's 66.
So we're at 66. And what is that 66?
Average cost function.
So the average cost function was C bar of x. This is C bar evaluated at 100. So this is
Average cost of that.
the average cost of a set of headphones when what happens? Not when you buy 100, but when produce 100. Okay? So it's this is, first of all, we can say it is $66 per headphone set. But to explain the meaning context scenario, so when 100 headphones are produced, the average cost is $66 per set. Okay. So that's when that 100 comes into play. And 100 headphones are produced. Start to say produced. Gosh. The average cost is $66 per set. Okay. Let's see if we can knock out number 4 also.
So,
I said we'll see.
ABCD.
Maybe.
Suppose there's new Bluetooth. What?
New Bluetooth headphones from example 3, and they sold for $125. Now, first of all, it asks us to write the revenue function. Notice there's no space here, so it's just writing it. Now, does it say anything about revenue back on that previous page?
Total revenue received from the sales of X units are.
Total revenue received for the sale of X units. So, how much are you going to receive here?
$125.
And how often are you going to receive that $125?
Every time you sell a product.
And how many products am I selling?
100. 100 more?
We don't know.
Wait.
Just we're writing a basic function.
X.
X. So my revenue function, 125x. Because $125, that's the money you bring in, times each unit. We're at X units. We don't have a number to plug in right now. Okay? Now, profit function. What's it say about profit?
Revenue minus cost.
Revenue minus cost, yes?
Yeah.
And when it says that, officially, it says pi of x is equal to r of x minus c of x, yes? So, I'm going to write this, and then we are going to clean it up. What is r of x? 125x. Minus, what's c of x? The one on the other page.
Oh.
So we're subtracting
Oh, shit.
1,500 plus 50x plus 1/100th x squared. Now notice I have that whole thing in parentheses, yes? Because it's the revenue, which is 125x, minus that entire cost function. Can we clean that up a little bit? We can. Like terms, it's 125x minus 50x, yes? 125x minus 50x is going to be 75x. And then we have the other two terms, so if I keep them in order, I'm going to say negative 1500 plus 75x minus 1/100th x squared.
Boom.
Okay. Marginal revenue. D&E or where I'm going to slow us down, but marginal revenue. Is that one listed? I'm not even sure this one's listed over on the other page. Compare it to marginal cost.
The revenue of one more.
And how did we find, what's our formula for marginal cost?
Derivative.
125
It was-
times x plus 1. No?
No, you're thinking more exact. Marginal cost is equivalent to C prime. So marginal revenue is equivalent to R prime. And what is R prime?
125.
That was a tough derivative, wasn't it? See, you have to think you've learned something this year.
Yeah.
You didn't know that a few months ago.
That's about it.
Okay, you've learned more than that, I promise. You have. Okay, D, compute the marginal profit function if 100 sets of headphones are produced and sold. Interpret your findings. Okay? So, marginal profit. What do we have? We have a profit function, yes? So what's marginal profit going to mean? Derivative. So pi prime of x, if you will. So what's the derivative of our profit function?
75 minus 0
Minus 200x. Okay. And what they ask us to do? Compute the marginal profit function if 100 sets of headphones. So now we're going to plug in the 100, which is 75 minus 2 100ths times 100, which is oh. Don't ask. Okay, the bell rang on me. I said 2 100ths times 100 was 200. Just don't ask, okay? That was my
It's okay.
that was my moment.
It happens.
So, 2 100ths of 100 is 2. 75 minus 2 is 73. Obviously, I did not make it through this. We'll talk about it tomorrow. Hey, and I thought I was doing good. Those last 5 minutes, like, poofed.